Welcome to our presentation. My name is Declan.
My name is Diego.
And my name is Anson. So, what is COMPSTAT? COMPSTAT is developed by NYPD, which is a data-driven performance management system that uses real-time analysis to prevent and reduce crime. Built on four principles, it shifts policing from reactive to proactive by monitoring trends, guiding deployment decisions, and ensuring strategic, equitable resource allocation effectively. What are the core processes? They are timely and accurate intelligence. Officers collect daily incident reports from patrol units into Excel files manually, which is to be analyzed and produce crime maps 3 times per week. The next one is rapid deployment of resources. Commanders use the outcome of analyzed data to allocate resources into high crime areas. The next one is effective tactics. Targeted patrol or community engagement are deployed with base in data presented in CompStat meetings. And the last one is relentless follow-up. Weekly meetings for crime statistics review and tactics effectiveness using PowerPoint presentations. Who uses CompStat? Crime analysts use Microsoft Excel to manually ingest, clean, and standardize incident reports, then generate the charts and hotspot maps that precinct commanders review to deploy patrols where they're needed most. Command staff and senior leadership rely on aggregated metrics, typically presented via PowerPoint, to oversee department performance and maintain accountability. What work do users perform? Crime analysts gather and validate daily incident reports from patrol units. They standardize and clean that data into Excel and GIS, and then produce the charts and hotspot maps and briefing slides that drive every CompStat meeting. Their work is guided by three critical questions. Which crime types are rising and where? Are current interventions reducing crimes? And which tactics proved most effective?
So what is the user's problem? Police commanders and analysts are experiencing inefficiencies and missed insights due to manual processes and lack of AI support. This leads to delayed responses, incomplete pattern recognition, and resource misallocation. Addressing this is crucial for proactive and accurate policing decisions. What is the significance? It affects decision making for dozens of officers per precinct. Late or incomplete insights mean true crime clusters may go under police. Additionally, it undermines accountability and stakeholder trust when metrics reported at CompStat meetings are out of date or suspicious. So what are the root causes? CompStat's inefficiencies stem from outdated technology. Excel and PowerPoint limit real-time analysis and offer no automation or predictive analysis. Organizational silos and a lack of in-house data science hinder integration and proactive strategy. Analysts face information overload without collaborative support, and opaque processes lack bias detection or fairness auditing, risking accountability. So what's the evidence that supports this problem? Manual data processing in CompStat relies on Excel, requiring auditing to catch errors. Analysts and commanders face cognitive overload preparing weekly briefs. Manual entry risks misclassification or manipulation, raising ethical concerns. Lack of predictive tools limits foresight. Our AI solution aims to automate cleansing, reduce workload, and enable proactive forecasting. So why does this problem matter? Growing reliance on CompStat demands higher data quality and integration. Without accurate, timely data, analysis stalls, and policing remains reactive rather than proactive. Manual data gathering is complex, slow, costly, and error-prone. Any bias or manipulation could lead to higher policing scrutiny over specific communities, intensifying social and/or ethnic inequalities.
So, what is the solution? AI model integration, redesigning of CompStat. Our Hi-Fi UE embeds AI into CompStat for human AI collaboration, enabling transparent and equitable decision-making. Key components include a dashboard overview panel for summarizing crime statistics by precinct, AI bias metrics to review AI outputs, an interactive viewer with visual data filters in geolocation, an AI reasoning panel for explaining outputs and data source viewer to ensure transparency on data sets and assumptions. How our prototype reports CompStat user goals. Our prototype helps COMPSTAT users detect enforcement disparities by highlighting bias metrics, generate and share audit reports for accountability, and understand AI model logic through explainable panels. By surfacing transparent, data-driven insights, it supports evidence-based discussions in COMPSTAT meetings, ensuring decisions are proactive, fair, and aligned with operational goals. What were the issues with implementing AI? Implementing AI faces three key issues. First, transparency. Black box models hinder trust and accountability as users struggles to verify AI-driven insights. Second, ethics. Biased data or predictions demand explainable or auditable outputs. Third, joint cognitive collaboration. Systems must handle human-AI disagreements by ensuring clear, shared decision-making pathways. Proportionate targeting of marginalized communities. Without transparency and explainability, officers cannot trust or defend AI-driven actions. Automating strategic decisions can erode human oversight, compromising accountability also. Over-reliance on AI also risks moral descaling, as users may lose critical judgments and ethical reasoning.
How do we address these ethical concerns? We tackle these ethical risks by using two distinct AI models, one for data sorting and another for presentation, so no single black box controls everything. We also built in a verification step that forces users to review AI outputs before the final. Above all, our AI emphasizes human-AI collaboration, keeping accountability firmly in human hands. Explanation. This verification loop emphasizes a classic feedback and confirmation pattern. By displaying the AI's inferred fields and then asking, is this correct? We apply Norman's visibility principles, making the AI's reasoning transparent so users clearly see what the system believes. This also bridges the gulf of evaluation as users can directly compare the AI's output against their own understanding and either approve or correct it. Requiring explicit confirmation before saving any AI-generated data prevents mistakes from propagating. In HCI terms, the simple feedback loop aligns the user's and AI's mental models, reduces cognitive uncertainty, and ensures that humans remain in control of every critical data entry.
Here is our highly interactive hi-fi UI prototype built with Figma. It consists of 4 windows. The first window is the NYPD login, where the user can log in with their credentials. Then the dashboard, which displays all the information, the report crime window, and the AI bias metrics window. When the user first launches the application, they will be presented with this login screen, where they can enter their details and click login. They are then presented with the dashboard. Here, they can enter a time frame to update some of the data on the page. So for this, we've selected the 1st of January 25 to the 1st of June 25. There's a map that displays the crime based on the likelihood run off calculations by data in the tables. There's an AI analysis insight, which gives an AI insight based off the information in the table. There is also a reasoning section beneath it. There's a crime type breakdown table and a crime rates table. Each of these display the crimes year to date, crimes last year to date, the percentage change, the crimes in the selected time frame, and the crimes in the selected time frame for the year prior. There is also a total crime rate graph with the crimes per day and the same time previous year for the selected time. Finally, there's a provide AI feedback window where police officers can submit any feedback about the AI output. You can also click on one of the locations to single it out, and this shows how the data updates. Now to the report crime menu. Here is where the police officer will describe the crime that took place. They must include the date, the locations, the people involved in their roles, the type of crime, and any other details. Here's a sample. Then they click Submit and Review. The AI will generate an output here, and it will also generate an AI database entry. Here, the police officer can confirm that these are the correct details before it is submitted to the database. If anything is wrong, they can click Change AI Output, and they could reprompt and tell the AI model what is incorrect and click Confirm. Once they're happy, they can click Submit AI Output. Finally, this is the AI bias metrics page. Here, a police officer can look at the AI feedback based on what users have stated in the dashboard feedback panel. There is also a graph here that displays the COMPSTAT crimes per day calculation and the AI crimes per day deviation, if there's any differences, and the table below will also show those differences. Finally, the user can log out again.
The design reasoning for the login page. In our login page, we have semantic mapping, as labels such as email and password sit directly above their fields, matching users' mental models of enter X here. Proximity compatibility. Each label, input box, and its helper links, such as forgot password, are tightly grouped so related controls stay within the user's perceptual span. The next one is Norman's visibility principle. The eye icon on the password field lets users instantly see or hide their input, exposing the password, preventing any entry errors. The next one is Miller's Law. We limit the login form to just 2 fields plus 1 action, staying well under the 7 plus or minus 2 item limit to minimize cognitive load. Gestalt principles. All elements share the same shape, size, and alignment, so they appear as a single logical group. White spaces separate the background city skyline from the form. And the last one is visual search performance. The gold login button pops out against the dark background, guiding the eye directly to the primary action. The design reasoning for the dashboard page. So we've got semantic mapping, such as the selected time frame label sits above the date fields, matching users' mental model of pick dates here. The next one is key functional relationships. Clicking a map marker highlights its row in the crime rates table, linking spatial and tabular data. The next one is proximity compatibility. Date pickers and refresh icons are grouped, showing they control the dashboard's data display. The next one is Norman's visibility principle. AI analysis insight box shows a bold heading such as loading text, revealing AI status to users. The next one is Miller's Law. Each panel contains fewer than 7 items, reducing cognitive load. And the last one is Gestalt principles. All cards share the same border and alignment, forming clear visual groups separated by white spaces.
On the design reasoning report crime page, we can see the semantic mapping in the enter crime details label sits directly above the text box, matching users' mental model of describe the incident here. Key functional relationships, submit and review sits next to the review AI output, linking user input to AI results. Proximity compatibility. We can see it in the AI output text box and review AI database entry table or group, showing their dependency. Normal visibility principle. Change AI output button appears in red, making error fix actions visible and obvious. Visual search performance. Green submit AI output button stands out against white space, guiding users to finalize their submission. Design reason and AI bias metrics page. Semantic mapping. Sections headings, AI feedback, AI output comparison sit directly above their content, matching user expectation to read commentary versus numeric data. Proximity compatibility. Each chart is placed immediately above its companion table, so users can compare visuals and exact numbers without shifting focus. Normal visibility principle. The AI bias matrix sidebar tab is highlighted in orange, making it obvious which page is active. Miller's Law. Feedback messages are chunked into short, scrollable cards so users process one comment at a time, reducing memory load. Gestalt, common region. All feedback cards share a light gray background and border, visually grouping them in one unified feedback panel. Visual search performance. Bold lines and distinct colors in the line chart stand out against the white background, guiding users to spot deviations quickly. Conclusion. By increasing the use of AI in all aspects of human activities, bring relevant challenges, not only technical but operational and ethical ones. In complex systems as COMPSTAT, the implication of involving AI may go from lack of transparency due to characteristic black box nature of all AI models to those derived from the traditional complex design framework that suggests an approach human as operator of AI. On the ethics side, bias, simplification, and transparency about the decisions achieved by AI models must be addressed to minimize its impact. Our approach aims to a collaborative human-AI collaboration work in which these operation COMPSTAT teams points to the achievement of the same goals based on its four core components. Our design involves AI presenting in the dashboard the result of its analysis, explaining the reasoning used and allowing feedback from human team, while on the crime report centering, it shows the results of the analysis it made based on the information given to the system. This approach laid the foundation for future developments in which the use of AI in complex systems consider the addressing of the implication of using this technology.